Hi everybody, today we will learn how to plot data on a graph and then determine the equation to describe the change of drug amount or drug concentration in the plasma over time. For example, we have a data set below. You get a data set of a drug A is determined of the amount of drug at different time points of 10 minutes, 20 minutes, 40, 60, 90, 120, and 130 minutes. For each time point, you have the drug amount is determined. So from this data set, how can you determine the drug elimination order and how to create equation to describe the change of drug amount over time? So from the data set here, first you will select the data. Go to Insert, select a graph, and you use the scatter plot here. From the graph here, you see it's a straight line, and this graph here is a kind of rectangular coordinates. To label the X and the Y for the graph here, you can go to a chart design, select add chart element, axis titles. For the Y bar, you will select the vertical one. And for the Y bar, this is the drug amount. For the X bar, this is the time. You go to chart design, select add chart element, axis title, and select horizontal. This is the time, minute. Okay, I can make the size larger. It's very easy to see here. All right. So look at the graph here. It's a rectangular coordinate, and the data you obtain from the graph is a straight line. So for this elimination, you can see that the elimination follows the zero order kinetics. To determine the concentration of drug as initial or any like the equation to describe the drug elimination over time, you click from to the time point, right click, and you select add trend line. This is a linear, so you select the linear here, then select display equation on chart. You can make the size larger for this equation. So this equation is y is equal to negative 0.7832x plus 104.23. Or we can rewrite like this. So from here, y you can write like this. Y is equal to 104 times 23 minus 0.7832x. From the equation here, you can see it's similar to AT is equal to A0 minus K0 T. X is the time and 8 is the amount of drug. 8 is the amount of drug at any time t. So from this equation, if you know the time point t, then you can predict the amount of drug in the plasma. From this equation, AT is similar to AT is equal to A0 minus K0T. So from this equation, you can see that A0 is equal to 104.23 milligram. And the elimination constant K0 is equal to 0.7832 milligram per minute. So using Excel is very simple, and you can determine the order of a drug by plotting the data on the graph. And you always start with the rectangular coordinates. And this is a straight line, so it's follow the zero order kinetics. And from the straight line, you can find the equation to describe the straight line. And from there, you can determine the initial amount, elimination rate constant, and also the equation to determine or to describe the change of drug amount over time. This is the data of another patient in another patient. And from this data, you will determine the drug elimination order, as well as determine the equation to describe the drug amount changing over time. So from this data, as previously, you have to select the data first, go to Insert, select the scatter plot, and for this data, you see that it's a rectangular coordinate. However, the line is not a straight line, it's a curve. You can label the X and the Y using the chart design. Go to chart design, select the axis title, a vertical for the amount drug or for the Y bar. So this is a curve. It's not a straight line on rectangular coordinates, so the elimination doesn't follow zero order. Now we will to determine the order of the drug, elimination of the drug, and also to determine, to establish the equation to describe the changing of the drug over time, we need to take the logarithm of the Y bar here. And to do this, you just select on the Y bar, right click, click on Format Axis. In here, you will select the logarithm scale here. So when you take the logarithm here, the Y bar, from the Y bar here, the curve will change into a straight line. So this elimination here follow the first order kinetics. And to determine or to establish the equation, describe the straight line here, right click on the time point, right click on the point here, data series here, and then you go to add trend line. Remember, this is a semi-log paper. It's not rectangular coordinate, so it's not a linear. You need to select the exponential for the straight line here, equation for a straight line, and then display the equation on chart. The equation to describe the straight line in this semi-log graph here is y is equal to 80.242 times exponential minus 0.032x. Y is the drug amount in milligram, and X here is the time in minute. So I can write like this. Amount of drug, here drug B, I can say B. Amount of drug at any time t, I call BT, is equal to 80.242 exponential minus 0.032x. So this is similar to the equation for the first order kinetic BT is equal to B0 times exponential minus KT. BT is the amount of drug at any time t of drug B at any time t. B0 is the initial amount of drug. K is the elimination rate constant, and T is the time t. So from this equation, I can rewrite this ABT is equal to 80.242 exponential minus 0.032 t. So from this here, we can determine the initial amount B0 is equal to 80.242 milligram. Elimination rate constant is equal to 0.032, and the time here minutes is per minute. So using Excel, you can simply determine the order of the elimination rate, and also you can quickly determine the initial amount of drug and elimination rate constant, and as well as establish the equation to describe the change of the drug amount over time.